My furnace runs about 30 seconds, then shuts off, then starts again in about 30 seconds and does this over and over.
Hello, I would like to help you with this. There is a part in the furnace that looks like this picture. Full-size image. It is called a flame sensor. This is your most likely culprit. The good news is that if this is your problem, all you have to do is remove it so you can sand it really clean and shiny, and then put it back.
Okay, is it hard to get to or replace?
It is not bad at all. Is your furnace in a closet?
No, it's in utility room and real easy to access.
Very good. Turn power to the unit off. Use a 5/16 nut driver to remove the screw holding down the flame sensor. Use sandpaper or a file to clean the sensor back to its former shiny self. Then do the reverse to install it. It's not too bad at all. Think you can do that?
All I have to do is find the sensor first.
The sensor is located so that it sticks into the path of the flames.
Found it. Now to find my 5/16 wrench.
Very good.
That took care of it, thank you very much. Does that need cleaned every year?
Wonderful. I feel that it does need to be done yearly.
Okay, hardest part of that was finding my socket.
I hope that in the future you will come back when you need something again.
You can be sure I will. I have used you guys before and will again.
Thank you again.
You also.
Hello. The two aspects that must be proven to ensure operation of your unit in this regard are the induced draft proving switch and the flame proving/sensing circuit. Either one of these safety monitoring devices dropping will create a fault and recycle the sequence of operation as described. 50 milliseconds in regards XXXXXXXXXX flame sensor to 2 seconds for the pressure switch to do this. A power disruption for 50 milliseconds can do this as well, however the power disruption is not a continually repeating condition as you describe. Some units will do as yours is indefinitely, others will cycle for a set number of retries and store a fault and lockout. These controls adapt when first ran to time their ignition periods and are continuously readjusting the time periods so as to be most efficient use of the igniter and assembly, until it cuts it too short and recycles with 2 additional seconds until it finds the sweet spot and locks into this set duration. Until that duration is unsuccessful, then the board tries to relearn the parameters that best work for the unit. In your case, first one needs to assert the pressure switch is not wavering opening/closing due to obstructed induced draft proving switch's hose, or more commonly the barbed port at which it connects to the induced draft assembly. This port clogs annually in most units and is a critical part of servicing these units. I use a tiny drill bit to ream the port until I can feel/hear the bit touching the inducer's wheel inside the assembly. It's easy to think you cleared the obstruction. However, it must be confined as the carbon etc. that obstructs the port are really tough sometimes and are almost chiseled out. If the condensate line is not obstructed, that is also imperative to operation of the pressure switch. We need to monitor the high limit and see if the exchanger's ruptured/cracked as well. The heat exchanger has combustion gases in its interior and the supply air passes over its exterior. The cool supply air is above atmospheric/positive pressure, while the hot combustion gases are under negative pressure, vacuum, BC of the location of the inducer motor. The combustion blower assembly is mounted on the outlet side of the heat exchanger. This blower creates a partial vacuum, negative pressure, within the heat exchanger drawing the flue products out of the furnace. A pressure switch, draft-proofing switch, is used to prevent the ignition system from firing the furnace until it senses that a proper draft has been proven. At blower startup, the positive pressure on the supply air escapes/infiltrates via the rupture into the hot and under vacuum combustion side, continuously or momentarily bringing the pressure above atmospheric, causing flame rollout, tripped pressure faults. 80% furnaces once the heat exchanger and flue reach operating temperature create a deeper vacuum than a 90% unit, thus be less affected by supply air migrating via the rupture into the combustion air of the heat exchanger's interior. This is why the 90 and 95% rated furnaces have multiple pressure sensors and/or switches that maintain a differential as well as rollouts that are manually reset type. I hope you found my answer helpful. Please click on the excellent button above for my answer, even if you are a subscription member. This is necessary for me to be paid for my work and so that I can get credit for assisting you. Your question will not close, and you will still have the opportunity to follow up if needed. Please remember this is a dialogue. If you have follow-up questions, please use the reply button and ask. If you have additional questions, sometimes misunderstandings can occur. If I did not answer the question you thought you were asking, please respond with the specific question you wanted answered. Keith.
If you have a home improvement or appliance question and want to chat with an expert, now visit JustAnswer.com/YTHI.